right, all operators on countdown 1. Flight directors go for launch. Ignition. Stage separation. Booster landing burn center.
Hello and welcome to Starbase, Texas. It's 5:19 p.m. Texas time, and we are just over 31 and a half minutes away from Starship Flight 13, the second test flight of our next generation Starship, version 3. During our initial launch attempt last week, we had a clean countdown, loaded all propellant, and got all the way to engine ignition, where the vehicle executed a safe shutdown when its automated systems detected off-nominal startup on 4 engines. That safe shutdown ensured that both the vehicle and launch pad were kept safe. As we often say, the payload on these test flights is data, and even when we don't get off the ground, we learn some valuable lessons and improve from them. We're going to dig into the details of that in just a moment, but all of that to say is that we're here today and we're ready for our second launch attempt. I'm Kate Tice, Senior Manager of Quality Systems Engineering.
And I'm Nathan Commissariat, a civil engineer here at SpaceX. Today, we're coming to you live once again from just outside the Star Factory production floor, about 1.5 miles from the rocket on the pad.
Back in May, the first test flight of Starship version 3 delivered tons of data, and we'll be putting those learnings into practice today on Flight 2. All of this brings us one step closer to a fully and rapidly reusable vehicle, the key to enabling frequent flights to the Moon and Mars. Starship will also enhance Starlink's constellation and connectivity on Earth, the Moon, and beyond, while helping establish a network of AI data centers in space. Success on today's suborbital mission also opens the door for near-future orbital flights and our first attempt to catch ship on Tower 2 here at Starbase.
And this is an exciting day for the Starlink team as well, as we're planning to deploy 20 of the newest generation Starlink satellites. These sats aren't intended for operational use and will only be in space for about 20 minutes before demising. But during those 20 minutes, we're going to attempt to speedrun a bunch of tests. Things like deploying solar arrays, firing thrusters. We'll get into those a little bit later into the show.
Yeah, and what Starlink engineers learned today will be essential to deploying operational V3 satellites into the Starlink constellation on future Starship flights. These larger, more powerful next-generation satellites are designed to boost orbital capacity, strengthen the overall network, and deliver a noticeably better experience for our customers.
And as we've said before, Starship is a developmental program. What we're doing today is a test. We test in flight because it's the best way to rapidly iterate the design, and it's the best way to put the vehicle through its paces in the actual conditions it will experience during an operational mission.
Yeah, exactly. So while we have real Starlink satellites on board, the most important payload today is data. But no matter the outcome of today's test flight, excitement is once again guaranteed.
Now let's head a couple of floors upstairs where Dan Hewitt is just outside the Launch Control Center. How's it going, Dan?
Hey, Nate. It is going great. Hi to you and Kate. Hello, everybody else. I'm Dan Hewitt with SpaceX Communications. Happy to be here with you for another launch day. As Kate noted, our first attempt to launch this flight test last Thursday ended early in a pad abort. Let's dig into that a little bit. So 4 of Super Heavy's 33 Raptor engines aborted at startup due to issues with their aux turbo pumps. Those rapidly pressurize and feed liquid oxygen into the engine for combustion. For those of you that like to pay real close attention to the on-screen telemetry, you saw this at T0 during that first attempt. We command the engines to start up simultaneously. You get some slight differences as the engine adapts in real time, but you saw 4 not light up. So 4 out of 33, what exactly happened? We have a launch constraint built in where we can only be down 2 Raptor engines at liftoff. So the vehicle detected more than that, we're out. automatically aborted before the final T0 safely shut down all of the engines that started up. We dug through the data, and what we saw was some off-nominal spin response in the aux turbo pumps on 6 of the engines. So the most likely root cause was determined we were collecting some moisture inside of the pumps from previous operations, which then froze when we introduced that cryogenic propellant, and that either slowed those pumps down or stopped them completely from spinning. So for this next flight attempt, we swapped in 6 engines that were already at Starbase, and we did a test back on Wednesday that allowed us to check out the newly installed engines and spin the aux pumps on all 33 after they were chilled, check out their performance before we got into another launch attempt. We pulled a bunch of those engines off, as we said. We tested one on a test stand up at McGregor, helped screen for any other issues that might be hiding, and that one was actually able to do a full booster ascent burn. So got us in a good position for today. Even though we didn't get off the pad last week, we learned about the engines, the prop systems, how they perform in the flight environment. Already going to drive some changes to make Starship more reliable. We also got a real-world test of an abort that's designed to take place at one of the most critical dynamic phases of flight. We safely shut down 29 running Raptor engines, safeguarded the vehicle and the pad. A mountain of work goes into designing aborts. You've got software, hardware engineers just dreaming up bad day scenarios, how we want the vehicle to respond, just to give us the best possible path to maximize safety, preserve the mission and the hardware, so we're able to do that. All right, that was then. This is now Flight 13's second attempt. So things are looking really good at the moment. Just behind me here is the Launch Control Center. Everybody's on console, looking at the systems on board the vehicle and on the pad as we count down to liftoff. Propellant load is underway. We slipped a little bit into our window as we waited for some last couple of things to settle out, and we are targeting a liftoff at 5:51 p.m. Central Time. Weather today, you can see we've got blue skies. We're going to do a little weather corner here for a second because we were originally attempting to fly yesterday, and we didn't because of, we said, weather. I want to be clear, the cause of not flying was visibility. It had nothing to do with launch weather constraints. One of the key goals of this flight is to get very clear imagery of the tiles on Starship as we're flying it at a higher dynamic pressure. You can't do that when you have clouds completely obscuring your view through all of those critical phases of ascent. We're actually capable and legally allowed to launch into lightning because we've done a ton of testing, unique testing, analysis, studying aircraft capabilities, and it's designed because that's ultimately the cadence we want to fly at, like an airplane. We're going to utilize that new capability carefully, but we're very aware if we want to fly Starship as often as you could fly an airplane, you're going to have to fly in weather that historically would keep rockets on the ground. So we're doing that analysis, we're doing that testing to prepare for the future. Aside from weather, we're watching the range, both in the Gulf right here off Starbase and in the Indian Ocean. That's currently green, and we are not tracking any vehicle or pad issues that will preclude a launch today. Speaking of the pad, that launch infrastructure, it's every bit as complicated as the rocket itself. It's designed to operate in some of the most extreme conditions on Earth. In case you missed it, we had some pretty cool insight into what it takes to launch the most powerful rocket on the planet in the second episode of our ongoing documentary, Starship.
When we're only a week out from flight, my main focus is getting into flight. The thing that separates us from a lot of other companies is that we test fast and we test often, and that includes launches. We want to make sure the vehicle's all ready to go. We want to make sure the ground's all ready to go, but we also don't want to be caught in analysis paralysis.
Our main objective today is a 10-engine static fire. Aboard. On LVN1, looks like we kicked out due to 2 combustors from the apex bank being pelted.
There was a pad side abort called.
These things were holding like 5,000–6,000 tons of propellant plus the rocket weight. And it's like, okay, well, why didn't you guys simulate that? It's like, well, because we didn't have anything that weighed that much. Like, this is the first time we put anything on it that weighed that much. So there's just so much that you have to think about and be very paranoid on.
We kicked out early. All teams triage alerts, prepare for offload.
We actually had another pad abort on the diverter.
Basically, right during engine firing, it was so much noise and vibration that it actually shook the sensors that are located out in this area enough that they aborted us out of the test. We went back, obviously, afterwards and looked at all the data and tried to come up with smarter ways to basically still protect the integrity of the diverter throughout the operation while changing our parameters so that we were making sure that we would not abort again.
A flame diverter is like a super simple concept that is like not at all complicated in operation and is just absolutely murderous in the details. These are extremely sophisticated thermal load sensing devices. If they turn into melted metal slag, then you know that you got too much heat. If you melt this, you're hotter than aluminum melts. If you melt this, you're hotter than zinc melts. If you melt this, you're hotter than copper melts. If you melt this, you're hotter than Sharpie melts. So we're sub-Sharpie. We have all of this mass flow, all of this energy that is just absolutely trying to obliterate our pad. We want to give it a thing to obliterate, to keep from obliterating the things that we care about. And the thing we give it is water. The amount of energy that water can absorb is like miraculous. And so if you can get high enough pressure water in the right places and just allow it to flash boil that water, then it solves a lot of the problems for you. Like the idea is that the steel never gets that hot. The structures never get that hot because the water absorbs all that energy, turns to steam, and everything's okay.
So for this flame deflector on pad 2, we're sitting somewhere in the neighborhood of about 650,000 gallons per minute. That's approximately in the range of about like one entire Olympic swimming pool being drained in the course of a minute.
You're trying to look into this thing and you see how like glowing hot it is. It's just yeah, a pretty impossible environment to keep something happy in. But and you zoom in and the flame deflector's still there, so that's the reason we build those things.
Putting the rocket into human terms is something really tough. 65,000 pounds per second of propellant that is coming out of the engines. And again, just like 18 million pounds of thrust, like what does that number mean? I think of like 11 Ford F-150 trucks per second just zipping out of the bottom of the rocket. It's like imagine if you had the world's biggest machine gun, except for instead of shooting bullets, it was shooting pickup trucks, and it's just firing 11 pickup trucks per second out of the bottom of the rocket. It's like, do you think your stuff could survive that?
And it is so satisfying to watch the slow motion flame diverter shots.
Right, and just hear all the exciting stories of how we tackle these problems out here in Starbase. Super exciting.
Yeah, and by the way, if that looks like fun to you, come join our team. We are seeking scrappy problem solvers to help us build the future. Okay, let's go meet the rocket out on the pad, Starship version 3. It's the most powerful rocket ever developed and ever flown.
And it's also the tallest at just over 407 feet tall, fully stacked. It is massive. Standing at the base and looking up is like looking up at a 40-story building. Incredible.
Yes, it's a two-stage rocket. Both stages are designed to return to Earth and fly again, making that thing that you see on your screen the first fully reusable rocket ever. The bottom half, or the first stage, is the Super Heavy booster. That's the silver part. It's powered by 33 of our newest iteration, you see them there on your screen now, Raptor 3 engines. They run on liquid methane and oxygen, and this version of Raptor provides a significant increase in thrust. With that additional thrust, as you can see here by these comparisons, the version that we're launching today, version 3 on the far right, that version of Starship gets off the pad much faster than our previous versions. The one on the far left is, I believe, is actually our Flight 1 footage, and in comparison, they really just go.
Yep. And now Super Heavy has 3 grid fins, which you can think of as aerodynamic rudders. You see them on your screen now. They help steer during landing. They're 50% larger than on previous booster versions and are designed to support rapid reuse and a more stable atmospheric reentry.
I love that shot there. And at the top of the booster, we've got the hot stage adapter. It's designed to protect the booster during separation, and now it's fully integrated for reusability.
And stacked right above that is our upper stage of the rocket, or stage 2. It's what we call ship. It's powered by 6 Raptor engines, 3 optimized to sea level performance, and 3 for the vacuum of space.
Ship's design could one day enable point-to-point transfer on Earth, meaning you could travel anywhere on the planet in an hour or less. Sounds pretty great to me.
Sounds awesome.
It's designed to carry massive orbital payloads, both cargo and crew, to Earth orbit, the moon, Mars, and beyond.
And for the first time, we are carrying real Starlink V3 satellites to space. For more on that, let's head out to California, where Tyler is standing by with the team in Hawthorne. How's it going, Tyler?
We're doing great over here, Nate. Thank you both. I'm Tyler Lionquist, and I'm a Starlink business analyst here at SpaceX. Now, for those of you who have been following along, the Starlink version 3 satellites have been designed to take full advantage of Starship's payload capacity. And we're going to get our first look at those satellites today. The Starlink V3 is our next-gen satellite, and it includes meaningful increases in capacity, data density, and power generation. So we'll be adding around 20 times the capacity into the constellation on each Starship mission as compared to the version 2 satellites that we launch on Falcon. And that means that we'll be able to serve more people all around the world and with increasingly better high-speed internet. Like all Starlink satellites, the V3s are built at Starlink's site in Redmond, Washington, where we already build more satellites than anyone else in the world today. Now, the V3 sats are designed to support 1 terabit per second of downlink and 160 gigabits per second of uplink capacity. That's approximately a 10 times improvement in downlink capacity and around a 22 times increase in uplink capacity from the version 2 Starlink satellite. Serving this capacity to and from customers are the satellite's upgraded phased array antennas. The upgraded phased arrays are fed by SpaceX's in-house developed chips that were designed to serve customers more efficiently in both densely and sparsely populated regions simultaneously. And each Starlink V3 satellite is also equipped with 6 high-capacity 400 gigabit space lasers. Now, these 6 lasers will allow high-bandwidth traffic to flow uninterrupted between any 2 points in the world with redundant paths across a petabit laser mesh network. And if that wasn't enough, the V3s will carry 4 quad-band radio frequency backhaul antennas. And these will take advantage of the Ka, E, V, and W communication bands, allowing for an 8 times improvement in supported capacity compared to the V2 sats. And that's a lot of growth in capacity and capability. And as such, the new satellite design requires more power. So the solar arrays on V3 will generate approximately twice as much power as the current arrays that we fly on the V2 satellites. And they're also optimized to reduce drag in the lower orbital altitudes in which these new satellites will operate. But before we operationalize these satellites, we want to put them in a flight-like environment. These satellites were loaded into Starship last week ahead of that first attempt. And once deployed, the Starlink team will only have about 20 minutes of flight to speed run some of these tests before the sat's demise in the atmosphere. The team will attempt to run tests such as extending the new solar arrays and antennas, connecting with ground stations, and turning on the satellite's communication systems. And this is all part of SpaceX's iterative process to technology advancement. From the very beginning, Starlink was designed to scale rapidly and improve continuously. From production to launch and ground infrastructure, Starlink is uniquely positioned to keep pace with rising demand around the world. In fact, just last week, we rolled out the next generation Starlink kit, the V5, which is built for reliable, high-speed home internet.
All right, you heard from Tyler. A lot of work going on with Starlink. We've also started development on an entirely new satellite constellation, StarMind, our AI satellites. I got to sit down with Elon and Starlink's Director of Satellite Engineering, Ian Dahl. We covered a whole bunch of stuff, really focused on what are the 3 limiting factors to making data centers in space a reality. First one we talked about was mass to orbit. That's where Starship comes in. We're going to need megatons into low Earth orbit, and we're going to be combining its full reusability and the really big payload capacity to launch the number of satellites that we're talking about, because we plan to deploy up to 1 million AI satellites, and those are going to function as those orbital data centers using Starship for the high volume, low cost launches. A couple of really key reasons why moving data centers to space has advantages over building them here on Earth, which gets into our second limiting factor, which is power generation. It's always sunny in space. Satellites can harness that sun, that near constant solar energy, which is really going to be the only way to scale if AI continues to grow at the pace that we see, especially when you contrast it with all of the challenges that you have here on Earth. Within about 2 to 3 years, we believe space-based AI compute is going to become the lowest cost option as those launch costs continue to drop and Earth-based constraints continue to grow. It's going to just transform how Earth powers AI, unlocks the future. And then our third limiting factor that we got to go figure out is going to be chips, and we got to do that fast, and that's what we're doing with TerraFab. That's going to be the most epic chip building effort ever. Not just churning out really cool advanced chips, but also building a massive scale location to do it. We're talking 100 million square feet, so about 10 Tesla gigafactories. All of this together sounds a bit fantastical, a bit out there, but these are real steps that we are taking right now that are going to set us up to eventually become a galactic civilization. That sounds really cool. I mean, harnessing meaningful amounts of power from the sun, supporting all of those AI applications that are going to change our daily lives, and making humanity a multi-planetary species. If you want to learn more, you can watch the full conversation on our website. Hopefully a link appears on the screen. If not, go look up StarMind. So the future is looking pretty sweet, but first things first, we've got Flight 13 ahead. Let's jump down to Kate and Nate for what's ahead.
Thanks, Dan. Yeah, the future is built on progressive steps like today's test. So let's dive into the flight profile that we're going to see today.
That's right. We've got an exciting day in store. So starting with liftoff, Super Heavy will ignite those 33 Raptor 3 engines right off of Pad 2 here in Starbase. We will then power through ascent ahead of hot stage separation, where the booster will shut down all but 5 engines at the bottom. Stage 2 will then light its own Raptor engines, pushing off from Super Heavy and starting our stage separation maneuver known as hot staging. We will then have the directional booster flip using 33 engines, and after coasting for a few minutes, the booster today will target a landing burn and ocean splashdown a few miles off the coast of Starbase.
Ship is going to keep the party going with its ascent burn to a suborbital trajectory, followed by deployment of those 20 Starlink V3 satellites. We also plan to relight a single Raptor engine. Re-entry is just a few minutes later, which should provide some amazing views thanks to Starlink. And typically we see some pretty fantastic views of the ship's blistering re-entry through the Earth's atmosphere. A plasma blanket will form around the vehicle and never prevails to provide epic scenes. And lastly, we'll conclude today's test with a landing flip, a landing burn, and a splashdown in the Indian Ocean. And with that, let's kick it over to Dan for a countdown update.
Thanks, Kate. Good news. We just heard from the flight director. We are T-minus 10 minutes. We're a little bit past that now, not tracking any issues for launch today. Range continues to be green. Our range team hard at work, making sure we're clear out in the Gulf and in the Indian Ocean, where we're going to be sending the Starship. Weather continues to be gorgeous. Again, no clouds. We scrubbed our attempt yesterday, or didn't even try yesterday, because we had such poor visibility. Weren't going to be able to see those tiles on the way up. That's a key kind of experiment objective for this flight today. And so we're looking really good with weather today. In the future, we'll see what kind of adverse weather we can fly into. We are capable and allowed to launch into lightning, but we're going to utilize that new capability carefully as we eventually continue to evolve Starship to fly it at an airplane-like cadence. You can see the prop load there on your screen. We're just about closed out on the main tanks on the ship. We just started propellant load in the header tanks on Starship. Those are the 2 smaller ones up top that we'll hopefully be using for the in-space burn and a landing burn at the end of its mission. We started loading our propellant at about T-minus 35 minutes today, and we're going to continue all the way down until we're inside 3 minutes to launch. We'll close out at about T-minus 2 minutes and 50 seconds on booster, and then 2 minutes and 10 seconds on the ship. So at the moment, we're looking good. That launch time, 5:51 p.m. Central, a couple of minutes into our window today. So we'll be back real soon. Toss it back down to Kate and Nate.
Thanks, Dan. Recently, NASA announced the astronauts for the upcoming Artemis 3 mission. The Artemis 3 mission is a crewed demonstration mission in low Earth orbit designed to demonstrate critical systems needed for future lunar landings. Astronauts Andre Douglas, Luca Parmitano, Randy Bresnik, and Frank Rubio, as seen there on your screen, they will crew the mission, and it's slated for 2027.
It's a great crew, and it's also the penultimate mission, the final test before Artemis 4 attempts to put astronaut boots back on the moon for the first time since 1972. We'll be launching a Starship with a docking port on the nose so we can practice rendezvous and docking with the crew. And one key test objective comes after docking, where we will be able to test out maneuverability of the vehicles together while in space. This has the new importance as the revamped plan for lunar landings used Starship to do the burn, sending astronauts to the moon from Earth orbit.
And one other cool ad, NASA is putting 2 SpaceX mini lasers on Orion to connect it to our Starlink constellation with the goal of enabling 4K imagery and video from the spacecraft while in space. So that's going to be pretty awesome to see.
Awesome views for sure.
Yeah, there's lots of excitement planned for next year as we all work together to send humans back to the moon. And speaking of sending humans to space, former SpaceXer and current NASA astronaut Anil Menon is actually up on the space station right now as part of Expedition 74. And he captured these sweet photos of Starbase during an ISS flyover. Hi, Anil. We're all waving back at you, buddy. It's awesome to see the whole picture here as there's lots of facility and infrastructure development going on, but Starbase isn't alone on that front.
Yeah, it changes every day.
Yeah.
But talking about other locations, work is well underway in Florida to get pads 39A and Slick 37A ready for future Starship launches potentially later this year. Starship launches from Cape Canaveral are key to hit the necessary launch cadence to get back to the moon, build a moon base, head to Mars, all the exciting stuff ahead in the future.
Yeah, exactly. And that future gets closer and closer with tests like today's flight. And with that, we are just under 6 minutes until launch. So that brings us to terminal count. Excitement is definitely getting traction down here as the crowd is gathering just behind us on the lawn outside, and happy to say, still not a cloud in the sky. Dan, how are things up at Mission Control?
Things are still looking really good, Kate. We are still not tracking any holds on the board, no issues with the vehicle or with the pad. Our range continues to be green, both in the Gulf and out in the Indian Ocean for flight today. We'll continue monitoring that all the way down to the final minutes. We are going to be closing out our propellant loading on the booster and the ship within the next 3 minutes. We're going to have about 11.5 million pounds of liquid oxygen and liquid methane on both of those stages once we're all done. Then it'll be time for the pad to essentially ready itself, where we clear out all of the prop that's been flowing through feed lines up into the launch mount, up into the tower. Those go back into the propellant farm, get it ready, and we'll do those final thrust vector control, those steering checks as we get a little bit closer. If we need to hold that hold time, it's new for this launch, and we saw it briefly on our attempt last week. That hold is set at T-minus 60 seconds now. That's where we can pause, we can wait. If we need to just kind of hang out for any pressurizations, anything like that to clear, we've got a couple of minutes to hang there. We will only hold if there's an issue, and we're not tracking any holds on the board right now.
That's right. Now, once T-minus 60 seconds passes, a number of events will occur in rapid succession. Both the ship and booster will configure their comm systems for flight, and they will rapidly run leak checks on gas and fluid tanks. Meanwhile, the booster will be going to internal power, and its engines will get their final priming for launch. Those ship engines will also begin their ascent bleed profile, and it will arm its automatic flight safety system. There's a lot of mechanical activations on the tower side as well, with one critical step being unlatching of the quick disconnect feeding propellant into the ship.
And once T-minus 60 seconds has passed, we still have the ability to rapidly recycle the count under certain conditions back to that T-minus 60 seconds point and hold there to assess what happened and if teams can proceed once again to T0. There's an estimated 5 to 8 minutes of hold time, and that's largely driven by the propellant temperatures that we see on the vehicle while holding. The flame diverter on pad 2, you can see it there at the base of Starship. That activates at T-minus 17 seconds. Now, if we trigger a hold after T-minus 17 seconds, that will result in a scrub for the day, as we've already turned on the water. Now, for those that have just recently tuned in, once again, our primary test objectives for today's test flight includes a successful liftoff, stage separation. We also plan to deploy 20 Starlink V3 satellites. We have real satellites on board. We expect to have about 20 minutes of available time to speed run some tests and really allow the Starlink engineers to put them to the test in that time.
That's right, and we also have the soft splashdowns planned for both the booster and the ship. Going to be super exciting to see if we can return those safely back, so that way we can get ready for tower catches again.
And just a quick check-in, we got our final green light from the range, not tracking any issues on ascent or out in the Indian Ocean for entry, so that was kind of the final go for flight that we wait for in these final minutes. Prop load now closing out on both vehicles. We have no holds on the board. Again, that we've got that gate at T-minus 1 minute. We're only going to hold if there's a reason, and currently there are no reasons.
Now, coming up here in a few seconds, we should have, actually right there we can see on screen, that's the base of the Super Heavy booster. Those are the 33 Raptor engines, and we expect to see and there they go, the TVC checkouts, also known as engine wiggles. We're activating those thrust vector control actuators to ensure that those center engines and the inner radius as well have the ability to steer the rocket.
Yep, super cool to see how fast those move. I mean, in flight, it's amazing to see how it steers the vehicle. And we're coming up on that T-minus 1 minute now on our countdown, so let's listen in to see if we pass that gate.
All right, we are through the gate. Still no holds on the board. 50 seconds to go. Starship getting ready to fly.
Flight directors go for launch. -9, 8, 7, 6, 5, 4, 3, 2, 1. Lift off Starship.
Vehicle is pitching downrange. Booster Raptor chamber pressure is nominal.
Seconds into flight, 33 out of 33 Raptor engines lit on the Super Heavy booster, arcing away from us here at Starbase. Coming up on max Q, maximum aerodynamic pressure, which again for this flight is going to be higher than it has been on any of our previous Starship flights. So we're passing through that maximum aerodynamic pressure over a minute now into flight. Still seeing 33 out of 33 Raptor engines lit and burning. Our next major moment's going to be coming up in just a little over a minute from now when we're going to get to hot staging. We're going to shut down all but 5 of those engines on the booster. It's our version of MECO. Most engines cut off. And then we're going to ignite the 6 engines on the ship while it is still attached, to do that separation. As a reminder, we try to do a directional flip, so when you watch on your screen, we're hopefully going to be sending that booster towards the bottom of the frame. For the booster itself, it's like doing a flip up. It'll go towards the bottom of your frame. We do that by lighting the engines in a slightly staggered sequence. Standing by for hot staging. All but 5 engines down.
Cutoff. Accept.
6 ignite.
Backburn startup.
And the booster now doing its boost back burn. It looks like we lit all 33 initially. Now we're down to 13. We're seeing 6 out of 6 Raptors lit on the ship.
Backburn shut down.
And boost back burn shut down. So it looks like we were able to get through the boost back burn this time around. That was one of the key objectives we didn't have on the last flight.
Nominal.
And we've got 6 engines lit on the ship. All right, so that's the first of 2 burns that the booster is going to be doing to kind of send it back towards us. It's going to be landing a couple of miles offshore from Starbase, hopefully. We're going to try and get it all the way down to do a landing burn, where we're going to use those 13 center engines. They're going to ignite. That's what's going to really bleed off all that velocity that it's built up. And it'll eventually, hopefully, transition to 5 engines to kind of fine-tune its path in, and then all the way down to 3 for the remaining bit. All right, we've got a couple of minutes to go until we get there. So booster's going to coast for a little bit. Ship still seeing 6 out of 6 Raptor engines lit. 4 minutes into the flight, ship's got about 4 minutes left. Getting some killer views. Kate, Nate, how was the view from down there?
It was incredible. I mean, it just shot off the pad, and seeing all the crowd now running back inside to take views on the screen here, it was amazing.
Yeah, one of these days I'm gonna learn to not stare at the engines, because now I have a bright blob in my vision. Right. Now, speaking of vision, we could see both stages there on your screen. Starship's second stage is still firing its engines. You can follow along with that with the GUI down on the bottom right-hand side of your screen. Still following the planned flight path as well. Beautiful views of planet Earth there behind the ship.
That's right, and we're actually getting a live shot off the booster right now, an onboard camera. You can see the plume from Starbase where it just lifted off 5 minutes ago.
On nominal trajectory.
We are there.
We are there. That is us.
I kind of want to run back outside and wave.
Right. Now, again, this booster is not planning to come back to the tower or to launch site for this particular launch. We are going to be planning to do an ocean splashdown just off the coast of Starbase, so hoping to still get some amazing views of that.
Pretty awesome to see the Raptor engines there on the left-hand side of your screen. We can actually see the plume there of those center Raptors. Those are the sea level ones, as well as the vacuum Raptors are the 3 on the larger ones on the outer radius.
Now, just like on tower catches, we are going to be doing a 13 engine landing burn to slow the booster down. Hopefully we can get a live camera of the booster right now as we're going into that phase. Awesome shot, you can see it there. So right now the booster is using their 3 hypersonic grid fins to guide itself through the atmosphere toward its landing site. You can see we're only 5 kilometers above the sea right here.
Startup.
Just heard the call out for landing burn startup for the booster. I have a feeling the crowd's about to go wild here.
And another awesome landing for Super Heavy. Congratulations to all the teams here at Starbase and at our SpaceX team. An amazing, amazing view.
Everything continues to go well with ship, as you can see there on your screen.
Yeah, we've got about a minute left with the ship engines on. Just looking at the booster real quick, it didn't look like we lit all 13 engines that we were planning for that initial landing burn. We were targeting a softer splashdown, and as you saw, it came in with quite a bit of velocity still. So landing velocity did look a little bit high, but really cool to make it all the way back this time to that landing burn. We'll dig in, figure out how to turn on all those engines, and then get to a full landing soon. But all eyes on ship. We are just a little ways away from getting those engines turned off. We expect it to burn about 8 minutes and change. And so hopefully just about 15 minutes to go. Sounds like we just got the sonic boom
Yeah,
here
we sure
at
did.
Starbase
That was awesome.
from the booster splashdown. And engine shutdown. All right, Starship 6 Raptor engines have successfully shut down.
Nominal orbit insertion.
And there's our call out for nominal orbit insertion. So we got a ship in space. We've got a booster in the Gulf where we were planning to send it. It's a hell of a start to the day, Kate.
Yeah, it sure is. All of our colleagues here are filing in through the doors. A lot of people wanted to stay outside and hear the boom. And so it's pretty great to see a ship in space, and everybody's super excited down here.
That's right. And as guaranteed, it has been an awesome day so far. All this action in just 9 minutes now. And objectives are done for the booster. Just want to quickly flag that that booster did land in a clear zone. We clear those before launch, well ahead, so that we ensure everyone is safe before the launch and after. So we're getting ready now for our in-space objectives.
Yeah, we've got a few minutes until the next milestone, so sit tight and enjoy the space views and, of course, the space jams. We'll be back here at T+14 minutes to deploy our payload, which is 20 of our newest Starlink version 3 satellites. So we'll see you soon.